Our next speaker is Desean Lee from our lab here at Charles University on nicotine and hepatic and muscle steatosis.
Hi again. My name is Desean Lee, and I'm a research assistant here at the Charles R. Drew University of Medicine and Science. I'm here to talk about how nicotine stimulates de novo lipogenesis in mice, what causes intramyocellular lipid accumulation and intramyocellular mitochondrial abnormalities, but only when combined with high-fat diet. As we all know, and as a common theme in this symposium, is that cigarette smoking is bad. With that said, and being common information, approximately a quarter of Americans have smoked, which is very problematic when there's risk factors like cardiovascular disease, COPD, and lung cancer. Additionally, smoking and obesity are the leading causes of mortality and morbidity worldwide. In our lab, we've actually produced increasing evidence showing that smoking also contributes to non-alcoholic fatty liver disease and has a direct adverse effect on muscle. We're actually going to focus on some of those direct adverse effects on muscles throughout this presentation. And lastly, obesity exaggerates health risks associated with smoking. So from some of our previous experiments throughout the years, focusing on high-fat diets and smoking, what we see is that animals on a high-fat diet that are treated with nicotine, they weigh less. However, if you go to B, you'll see that they don't eat as much either, which is indicative of the fact that nicotine is an appetite suppressant. Also, looking at C, you see that there's more fat in the blood, and D, there's more fat in the muscles, and E, we find through the muscle GSH-GSSG ratio, which is an inverse relationship in that less is more. We see that high-fat diet plus nicotine makes for more oxidative stress, which is really bad, simply. So studying the muscle morphology, what we find is that in normal child diets, we see things that are normal. We see normal mitochondria, we see normal muscles. But when we get to high fat, you start to see, a slight change. And nicotine plus high fat diet causes intramyocellular lipid accumulation and intramyocellular mitochondrial abnormalities in obese mice. And what you see with the arrows is you see these fat globules that are juxtaposed with mitochondria. That's the IMF mitochondrial abnormalities and the asterisk. And then in F, what it's pointing to is the lipid accumulation. And those are things that aren't normal and are very bad and not good for your health. So we also investigated the metabolic pathways, focused on the AMPK pathway and its downstream target, ACC. And what we see in high-fat diet plus nicotine is that the AMPK pathway is turned off and its downstream target, ACC, is turned on, which is abnormal when you look back at normal child diet and saline, or even a normal child diet with nicotine, where you see everything is normal. It's what it's supposed to be, right? So then, looking into that, what we find is that when you use Sipomox, which is a lipolysis inhibitor, it normalizes even high-fat diet with nicotine, which we see are our worst results. But with the Sipomox, it reverts the metabolic pathway to something that's more normal, which means that this sort of lipolysis is causing these pejorative events. So our next idea was, okay, well, it's fat that's causing this problem. Where is it going and where is it generated from? Focusing on where it's generated from, we investigated de novo lipogenesis. And for your viewing pleasure, this is the pathway starting from glucose or glycogen, leading all the way up to fat. So our objective was to determine the role of de novo lipogenesis in the development of skeletal muscle abnormalities in nicotine-treated mice on a high-fat diet. And to do this, we used C57 black 6 mice that were either normal child diet or high-fat diet and treated them with either nicotine or saline for 10 weeks. To measure de novo lipogenesis, we gave animals deuterated water 2 weeks before euthanasia and let de novo, just to give de novo lipogenesis time to reach a sort of steady state. And to measure de novo lipogenesis, we use gas chromatography mass spec analysis to see exactly how the deuterium isotope integrated itself in fat. And we actually got that fat from gastrocnemius muscles in the mice that we treated for 10 weeks. And what we saw was that de novo lipogenesis happened as a result of nicotine treatment. And that result happened even in the NCD, the normal child diet nicotine group, which was unexpected, but still a good find. And I'll explain that later. So we studied the muscle morphology in these animals as well. And we found, similar results where normal controlled diet, everything is fine. High-fat diet, you start to see some changes, but again, nicotine plus a high-fat diet causes IMCL accumulation and IMF mitochondrial abnormalities in obese mice. And again, you see the fat globules right next to mitochondria and throughout the muscle cells and the gastrocnemius. And again, we wanted to look at the metabolic pathway. Let's see if these are different, and they're not. They're exactly the same. Where you see the AMPK pathway is off and its downstream target ACC is on. And again, that's that means that the pathway is in disarray, which allowed us to summarize that nicotine in combination with a high-fat diet causes intramyocellular lipid accumulation and intramyocellular mitochondrial abnormalities. These detrimental effects of nicotine and a high-fat diet on the skeletal muscle is associated with the inactivation of the AMPK and activation of its downstream target ACC. And lastly, that nicotine stimulates de novo lipogenesis in mice that consume either diet. So in conclusion, muscle de novo lipogenesis may have little or no contribution to nicotine plus high-fat diet induced IMCL accumulation and mitochondrial abnormalities. And these results, however, underscore the importance of AMPK and ACC in mediating the effect of nicotine on skeletal muscle abnormalities and diet-induced obesity. Thank you, Dr. Freeman, for inviting me. And open up to questions.
Great, Sean.
Yeah, so muscle de novo lipogenesis.
That means making new fat directly in the muscle,
that means,
as opposed to the fat coming from the liver and from other parts of the body, from the abdomen. So it didn't show new fat made directly in the muscle, but it got the fat most likely from breakdown. Nicotine causes breakdown of fat in the abdomen, which goes in the bloodstream to get deposited in the muscle.
Yeah, so when we have the high-fat diet plus nicotine, we see these effects. Right, so it's like, where does the effects come from? So we investigated de novo lipogenesis, but de novo lipogenesis happens regardless of diet. So it just happens because of nicotine. So what we're seeing in high-fat diet can't be caused from de novo lipogenesis de novo lipogenesis may have little or nothing to do with it because of the fact that we see de novo lipogenesis in both food treatment groups. Our results are more focused on the high-fat diet plus nicotine. That's when we see all these bad negative effects where you see the large fat globules and the mitochondria. Next question. Oh, okay. All right.
Okay. Thanks everybody for joining us this morning. Please return at 1:55. Dr. Carlo is going to give an afternoon welcome. The food is to the right over there in the tech auditorium. And why don't we have the trainees go first? Dr. Leslie is back there, and Dr. Joanna Fowler is over in the front here. Students, please welcome to join her and help get some advice in your careers. And see you back at 1:15. We have one poster. We may have another poster coming up soon over there.